While we're waiting for the last few people to file in, there are a few things I want to, things I want to go into. Let's see, first of all, there are now two different versions of my lectures which are probably floating around on the web. One are last year's lectures, which are on the UCLA site, on the Broomcast site. Has anybody tried to access those? Raise your hands high if you have. Not very many people, okay. Did anybody try and fail? No, nobody tried differently. Did anybody try and succeed? So there's nobody here. You were successful. Okay, so the one person that tried, okay. Did anybody try and fail? Okay, so it's a good batting average, but it's not very significant. Okay. Secondly, there is the Camtasia thing from the last lecture that I put up that's on YouTube. Does anybody from the last lecture? Did anybody see that? Look at that. Oh, people did look at that. Is it there? You got it okay?
Yep.
Did you try to do it full screen or just keep it small?
Full screen.
Was it fuzzy?
Pretty good.
Okay. All right. Okay. So is that worth doing?
Yep. Good.
All right. So we'll do that. Also, pretty soon I'll get it fixed so that I can also have the pointer working on that. But I have to download something that I haven't downloaded. Third question. Has anybody done the video talk on genetics? Looked at the video talk on genetics yet? Okay. How many here hands? Real high. Okay. All right. I have a question for you guys. I'll get you each way. Yes. I want you to vote. Everybody should vote on one of the two propositions. You'd rather have that material presented in that way versus you'd rather have that material presented as an in-class lecture. How many would rather have it presented that way? Raise your hands high. How many would rather have it as an in-class lecture? More. Okay. It won't be this time, obviously. Does anybody have so is that because of the way it was done, or just because you prefer it as in-class lectures? I don't know if anybody have anything to say about it?
Well, if you did the stuff as an in-class lecture, what would happen to the material that we would have covered?
I don't know.
Okay, that's
I
why.
I'll figure it out. I don't know. But I mean, just assuming that one way or another that would be. And well, actually, what would really happen probably is it would be briefer, and I would have left a lot of stuff out. It's probably what would have happened, and that's what's happened in past years. Was it generally? I mean, you won't hurt my feelings too much. Was it generally comprehensible or not? How many thought it was generally comprehensible? How many thought it was not? Okay. So there's some issues about this that I actually want to get resolved for future use. And what I think, I expect that some of you will be embarrassed to, or not want to send me something negative that I know is coming from you. So what I am actually going to do is I will set up an email address and a password that you can use to send me emails as anonymously. And then you can tell me, I'll probably ask you some questions then that I'd like to know the answers to about how that various things work. Because we may change this class around some in the future, and I'm trying to get a sense of what the best way to do it is. Okay. So it was comprehensible, but you'd rather have it as lecture. Can anybody say why they'd rather have it as lecture? Okay. I'll ask you that question again when you can respond anonymously and see if I get any more information. Okay, I guess that's the administrative business that I want to do. Has anybody tried to take the quiz? Did it work okay? I don't care. I mean, yeah. Now, you're not yet ready. I mean, you haven't had all the information you need to take it, but that's fine. You can take it as many times as you want, so I'm not concerned about that. Okay. Okay, anything else? Any other issues anybody want to raise? Yes?
I changed my answer to wanting the lectures online so that we don't have to go briefer for anything again.
So say that again.
I changed my answer to wanting the extra stuff online.
And because why?
Because then we have more lecture.
More stuff.
Yeah.
Okay. Well, that's that's a good attitude. Okay. Yeah, and you get more information that way for sure. If you want, some of you want the information, and some of you probably rather have as little information as possible. So okay. Fair enough. Okay. I mean, also, it was really painful to make it. So hopefully, I'll get better at it, or at least it'll get easier for me. I'm not going to do a lot of it, but there will be a few other things. I'll probably try to do that way and see how, partly in order to get better at it myself. Okay. So we were talking last time, beginning to talk about the extent to which some of these traits, these interesting psychological traits like IQ and introversion, extroversion, and so on and so forth, to what extent differences between us in traits like that are due to genetic differences between us or differences in our education, upbringing, rearing, and so on, upbringing, and so on. We looked at first at this number, which is biological parent-child correlation, and as somebody pointed out in response to a question, that tells us nothing because the parents provide both the environment and the genes. And then we added this piece of information, which was that there's a substantially higher correlation between a biological parent and its child, where the child, and an adoptive parent and his child, where the adopted child was adopted within days of birth. And the obvious implication, the most straightforward implication of that is that the reason for the difference is that the biological parents supplying the genes and the environment, whereas the adoptive parents only supplying the environment. So that's the obvious interpretation. But I asked you to think about the question of whether, if you didn't like that conclusion, because some people don't want to believe that there is any genetic component of variation between us and IQ. If you don't like that conclusion, how could you wiggle out of it? Yes?
You say that the circumstances surrounding adoptive parents are less conducive to like intelligence creating.
Intelligence creating. So what you... Yeah, I mean, that's kind of the one that I thought of. So basically, the idea is that I'm going to rephrase it in my own terms, but it's the same idea. When biological parents, certainly the mothers, and maybe even the fathers, but certainly the mothers have all sorts of hormones floating around that allow, they cause them to treat their kids in very particular ways, and so on and so forth. Adoptive parents don't have those, or at least probably don't have them to the same extent. And it may be all those factors of biological parenthood, as opposed to adoptive parenthood, may, for some reason, I'm not saying that it is so, but it could conceivably be so, that those factors that are present in natural parents that are perhaps not present to the same extent in adoptive parents might make the parent-child interaction such that for some reason it's less conducive to the parent having the same kinds of influence on their child. And so if some of those influences are things that affect IQ, then you might get a lower correlation in IQ. And that's not necessarily better versus worse IQ. It's just that the higher IQ parent might do things that make its kid a higher IQ, and the lower IQ parent might do things to make its kid lower IQ. Or might not do the things that would make it a higher IQ. So that is a possibility. I know of no data which suggests that anything like that goes on, but it is imaginable. So if you don't like the conclusion, there is that possibility that you can fall back on. And maybe there's some others. I actually haven't had anybody in the class suggest any other one ever, and I've been doing this for a while. But that doesn't mean, I'm sure there are other possible explanations. But that one's a little far-fetched in my mind. I mean, so you can make your own judgments about it. So if that was the only explanation I can think of, and it is the only explanation I can think of, I would say, well, probably that really is evidence for a genetic component to IQ. Let's look at some other data. We did, I guess, last time, look at another kind of data, which is this data which is comparing identical twins reared apart to unrelated children reared together. And again, the correlation is much higher for the identical twins reared apart, whereas the thing here that, at least on the face of it, is causing the similarity is entirely genes. And the thing here that's causing that similarity is on the face of it entirely upbringing, environment, so on and so forth. But there are some wiggles for this one too. Actually, the wiggles for this one are actually more plausible than the wiggles for the other one. At least for now they are. Can anybody see what might be? How can you wiggle out? How might you wiggle out of that one if you don't like it? If you really thought it was really all environmental, what suggestions could you make to explain how you could get this data, despite the fact that there was no genetic cause of variation in IQ? Can anybody think of something? Usually somebody gets this. Somebody have an idea they just don't want to talk about? Raise your hand if you have an idea you don't want to talk about. Okay. Well, I hate to just tell you the answer. Yes.
That twins are probably placed in like.
Sorry again.
If they're twins, they're probably like placed in an adoption home or foster care place near each other. So like probably.
Okay, that's the right track. Maybe they're placed near each other, and that's probably not the case, or not. And even if they were near each other, unless they actually had contact with their old parents and so were in contact with each other, I'm not sure what that would do. But what that does suggest is the possibility that adoptions are not done at random. Okay? You say they're near each other, and I'm not sure if that would be right. But if I were going to adopt a kid, I would think to myself, well, I don't know whether IQ is influenced by genes or not, but I would want to hedge my bets. I'm a college professor, and I would like to have a kid who is smart enough to go to college. And I don't know for sure whether as I say, I don't know for sure whether IQ has in part a genetic variation in IQ, has in part a genetic basis. But to be on the safe side, if I could, I would try to adopt a kid that came from biological parents who were themselves well educated, so that I knew that these were parents that themselves could make it to college or whatever, and therefore, if there were a genetic component to IQ and to ability to do well in school, that would be likely to be present in the genes of this kid I was adopting. That's what I would do. And in fact, adoptive parents do often try to do that sort of thing. Now, it used to be, years ago, that they did it and they were quite successful at doing it. But now it's much harder to adopt kids, much harder to find kids to adopt. And so I think that probably now this is not so true. But there certainly was a period of time, a long period of time, when by and large adoption agencies would, if the parents said, I'd like to have a kid who came from a home where the parents both went to college, the adoption agency, insofar as they could, would accommodate. And so what that means, of course, is that insofar as that's true, and it's probably true maybe to some extent, I'm sure it is true to some extent even now, the adoptions are not at random, and so what you have is you have potentially, to some degree, had kids going from a highly educated home into a highly educated home. And so that in itself can induce a correlation in IQs. And the argument kind of goes, the logic kind of goes like this. This is not the slide you have. I made a different slide this morning. The slide that you have is the next one, which I'm not going to probably use. I think I like this one better. So assuming there is selective placement, we start with a couple of possibilities. What we're saying basically, if there is selective placement, it may be, and everything is really environmental, okay, no genes, or genes are irrelevant. Maybe both getting well educated and living with educated parents enhances IQ. That's probably true. Whether there's a genetic component or not, that's probably true. Secondly, educated parents, and this is our hypothesis, request and get children from educated homes, whereas uneducated parents don't, or less so. Okay, and that's probably also true. Okay, if both those things are true, and if the adoption agencies really do accommodate these wishes of the parents, then what happens is if a child from a high education home going into an educated home, and a child from an uneducated home going into an uneducated home, on the average, not totally, but there's a trend in that direction, and therefore these parents have high IQs because their own educations probably gave them higher IQs than they would otherwise have had. And they're going into an educated home where this adopted kid is going to have a higher IQ because it's going to have all the benefits of having educated parents and being well educated and so on and so forth. Whereas this other kid, on this line, the parent on the average probably has a lower IQ because the parent themselves was not well educated and and going into an uneducated home, so again, lower IQ. So you have high IQ, low IQ, low IQ. So you induce a correlation. Even though there is no genetic basis for it at all. That could happen. And in fact, it certainly does happen to some extent. The question then becomes, okay, yes, it happens, but is it sufficient to account for the kinds of differences, or the kinds of similarities we see in the IQs of identical twins who are reared apart? The answer is probably no. This is my other explanation. You can look at that. You might find that slide better, but I'm not going to present it. That's the one on your flash, and that you have. By the way, if you remind me to, at some point, I will give you updated versions of the slides, so you'll probably have to pester me to do it or I'll forget. In any case, so here are these correlations we've been talking about. Identical twins reared apart, 0.8, and unrelated kids reared together, 0.38. Now the question is, can selective replacement account for that high correlation? A way to find out is to look at the actual correlation in educational levels of of the homes from which the kids came to the homes in which they were put. And the answer is there is a correlation. It's 0.3, and it's statistically very significant, but it's nowhere near as high as 0.8. So it's very hard to see how you could get a 0.8 correlation in identical twins reared apart based upon selective placement. So there certainly is some contribution, or most likely is some contribution of selective placement to the correlation in IQ between identical twins reared apart, but there's something else going on, and it seems, and there are very few scientists or psychologists there are some, but there are very few psychologists who think that there's not a genetic component to this. How big it is another, what portion of the total there is not clear. It's clear that there's an environmental component. It's clear that there's a genetic component. What the relative balance is, there you don't get agreement. Some people say one's very high, the other's very low, but they'll say the other way around, and there's not a universal agreement on it. Okay. Let's look at some other traits besides IQ. There's a lot of old data on this, which is relatively easy to get. And here what we're doing is we're going to compare identical twins reared together to like-sexed fraternal twins reared together. So we're not going to take brothers and sisters. We're going to take brothers and sisters over here. And the identical twins are by definition the same sex. So they... so identical twins are clones of one another. Fraternal twins, or brothers and sisters, same thing. I mean, from a genetic point of view, the same thing. It's just that they're born at the same time and share the womb. It's commonly said, they have 50% of their genes in common. Now, that's not accurate. They have 99% plus of their genes in common. But what it really means when you say they're 50% in common is this down here, and you can read this at your leisure, the details. The important point for us right at the moment is simply that these guys are clones and these guys are not. They're similar genetically, but not identical. Okay, so the argument goes here that if you compare identical twins reared together to like-sexed fraternal twins reared together, then if these guys are higher than these guys, that's presumably because of their identical genes, because their genes are identical, because they both have the same environment, at least on the face of it. Okay, so we can quibble with that, or think about quibbling with that in a moment, but if we accept that, then it's interesting to look at the rest of this data, because these are some of the traits I talked about first day, that I raised first day class. Can you see, am I in your way? You of all people have to see this. Okay, mathematical aptitude. Okay, well, you all wanted to believe that. You all wanted. So this says there's a much higher correlation in identical twins who are genetic clones of one another than there is fraternal twins who are not genetic clones of one another. And that says that would, on the face of it, that suggests that there's a genetic basis, at least in part, for mathematical aptitude. And that's what you all thought anyway. I think you thought it for bad reasons. You thought it because you wanted to believe it, but nevertheless, that you were right, according to this data. Social introversion, most of you didn't think was genetic, but it's whoppingly genetic, according to this data. Whoppingly genetic. Psychopathic deviancy, we didn't discuss. That's being a sociopath, going around and, well, we haven't seen a lot of examples of that in newspapers. Well, those people are fucking crazy. They probably weren't sociopaths. But anyway, sociopaths who have no superego, no conscience at all. And that's also highly genetic according to this data. Depressive disorder, also. Schizophrenia, or tendency towards schizophrenia, also. So very big genetic component to all those things. All right. Suppose you don't like that conclusion. Any particular one of those conclusions. How can you wiggle out of it? What could you say about that data, about this kind of data that would make you question the conclusions that I'm making from it. This isn't very hard. Think of, yeah.
Because twins are they're physically identical, you'd be more inclined to treat them
Precisely. Because twins are physically identical, you're more likely to treat them identically. Indeed, all of us know, I'm sure, have known twins, at least when the kids were little. The parents dressed them exactly the same way. They think it's cute, and da 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 da. Now the identical twins may in fact have more similar experiences to each other than non-identical twins. It's entirely possible, and that could be a reason, A reason or B reason or A reason for this kind of data. Certainly, it could sometimes be. The fact of the matter is, it can go the other way. So, for example, when I was a kid, I remember these twins in my class, Bart and Neil Warsanger. I remember the names. This is fifth grade or something. And they were identical twins, and their parents dressed them the same way, and so on. However, Bart was the good twin, and Neil was the bad twin. And in the end, Neil shot Bart, not on purpose, but accidentally. He got hold of his father's gun and was fooling around with it, and really didn't kill him, but he did wound him very, very seriously. And they were an example of the two twins living together, being dressed identically and so on, but trying to differentiate themselves from each other. They didn't want to be exactly the same. Some twins like it, some twins don't, and they didn't. And so they turned out very different from one another. So this idea that even though they look the same and they're treated the same, that doesn't always work. Sometimes you get exactly the opposite effect, which is actually totally irrelevant to this. I don't know why I'm dwelling so long, except that sort of. Anyways, but that is a possible thing that can be going on in this data. So this data has to be taken, and is taken, with a grain of salt. Because there are these kinds of issues about this kind of study, a much more difficult kind of data has been collected. It's much harder to collect, because it's much harder to get cases. But there are, as we've already talked about, some cases where identical twins are separated early at birth. And most of the early studies on this were done with IQ. But more recently, it's been done with other traits as well. And here are some of the data from the biggest of these kinds of studies that I'm aware of. Here's IQ again, just for reference. Now, the extroversion, conscientiousness, specific vocational interest correlations, and religiosity. And it's very interesting. If you look at identical twins reared apart, there's an amazingly high correlation for extroversion, for conscientiousness. That is to say, to what extent are you planful, organized, responsible, dependable, versus impulsive, careless, irresponsible, and undependable. Vocational interest. There is a tendency, a highly statistically significant tendency in these studies, for if twin A wanted to be a fireman, or twin B also wanted to be a fireman, even though they have never seen each other. They're raised by entirely different families, not necessarily even in the same city. That's pretty amazing, but that's what this data says. Religiosity, not any specific religion, although I wouldn't be surprised if there weren't even some correlations there. But mainly just tendency to be religious. Again, very high. I'm not 1.0 correlations, but 0.49 with a lot of, if there's a lot of data, which there is, or a fair amount here, are statistically very significant. So those are very surprising conclusions. There's something else interesting to be. So the bottom line of that is that there looks to be a tremendous genetic component to aspects of personality that one might not have expected when we're making one's intuitive judgments to have a genetic basis. But this data says there is, and I think it's. I don't know. The means vocational interest stuff. I don't know if that's generally accepted or not, but that's what this study says. I'm sure there are many people that do accept it. There probably are some others who don't. But there's something else interesting about this data. These correlations are highly statistically significant, but they're not anything like 1. All right? So, they're 0.5, in the range of 0.5. That says that there is something over and beyond genes that's influencing these traits. Okay? Because if it was just genetic, the correlations would be higher than they are, as they are for, sorry. They're not that much different, actually. Anyway, sorry, let me say that again. For IQ, there's not a real great correlation for the identical twins reared apart. I mean, it's good, but it's even better for the identical twins reared together. But notice that's not true for these other traits. But that's what you expect if parental environment is the other factor that's influencing variation. So we got genetics influencing variation, gene variation influencing variation, and upbringing variation influencing, causing variation in the trait. And that's true, and then it's consistent that those two factors together probably do account to a considerable extent for IQ variation. But that's not true for extroversion, conscientiousness, and these other things, because there's no higher correlation for the twins reared together than there is for the twins reared apart. So what's going on? So if there's no, that says there's not an environmental, or seems to say there's not an environmental correlation. And yet, if it's not an environmental correlation, why aren't these correlations higher? Because these are identical twins. So that's was a bit of a mystery when people first saw it. And then they said, of course, it is environment, but it's not home environment. Everybody knows that the big influence on kids, is certainly past a certain age, is their social milieu. It's their things happening in school, all kinds of other stuff outside the home that are not necessarily the same for two identical twins, whether they're reared together or reared apart. And so what this data seems to suggest is that the environmental influences on these traits other than IQ is considerable. But it's not exercised by the parents. It's exercised by the teachers and the peers and the so on and so forth, which, if you think about it, isn't very surprising. But at first, when people saw this data, they were kind of puzzled. In fact, we all know that the development of adolescence and so on is heavily influenced by things outside the home. So it's not such a surprising conclusion, but it's sort of an interesting one. I guess I don't want you to think about that now. You can look at that slide some other time. The real point is on the slide. Now, there's very general agreement, I think, that a lot of these traits, certainly IQ and many of the others as well, are influenced by both, variation is due to both environmental variation, whether home or outside the home, and genetic variation. But people would like to know how much of each. That gets much, much trickier and harder. And there's not a lot of agreement on that. This is a slight simplification. At least some things out that a competent geneticist or psychologist would put in, but I just want to giving you the idea. The way that there's a number called heritability. Let me back up. The general way that people think about this is say, okay, you've got a certain amount of variation in the phenotypic trait, IQ, conscientiousness, introversion, whatever it might be. And that variation has two sources. One source is the variation due to gene variation, and the other is the variation due to environmental variation. Okay? And in the simplest possible model, these two sources of variation simply add up. Now, they're not going to be perfectly additive, of course, and how do you measure each individually anyway? But conceptually, that's the way people think about it. In a sophisticated approach, there's also an interaction between the two, but we don't have to worry about that. Okay, having that in mind, if you can find a way to measure the phenotypic variation and find a way to measure the phenotypic variation due to genes and the phenotypic variation due to environment, you can then calculate a total variation, and you can measure the total variation. And the heritability is defined as the ratio of the variation due to the genes to the total variation. That is to say, the variation due to the genes plus the variation due to the environment. That's logical. So in other words, if you have a lot of variation due to the genes, then you're going to have a high variability. If you have a low variation due to the genes, you're going to have a low variability. That makes good sense. But there's a catch in all this. This heritability number is obviously going to be tremendously influenced by variation due to the environment, variation due to upbringing. If this number, for a given amount of genetic variation, fixed amount of genetic variation, if there's a lot of environmental variation, then the heritability is going to be relatively low. If there's very little variation due to if there's very little variation due to environment, then heritability is going to be high for a fixed amount of genetic variation, or variation due to genes. And this is an example that you can look at. I'm not going to go to it, but some societies are much more homogeneous than others. And in some societies, you expect most kids are going to be reared much more similarly to each other than they are in others. So, for example, I'm sure the kids in Sweden are all reared much more similar to each other than there are the kids in America. And so you can play with those numbers. You'll see. I'm not going to go through this in detail now, but if you play with these hypothetical trumped-up numbers, exactly the same genetic variation can lead, if you accepted these ideas, would lead to a heritability of the trait, whatever it was, in Sweden of 91%, and a heritability of the trait in USA to 50%. A big, big, big difference. So this heritability number is a very useful number, but it depends, it's sort of relative to the amount of variability there is in the environment and the upbringing practices of the society or the group in question where the data is collected. So that's something that is important to understand, and you will have some questions on that, on exams and study questions and so on and so forth. So the bottom line here is that heritability is relative. Okay. Now, another thing that is often talked about and often causes a lot of trouble is the fact that if you measure a variety, many different kinds of traits, including ones related to IQ, but also other traits, and look at different kinds of groups, blacks versus whites, girls versus boys, so on and so forth, you will find differences. And so, in fact, the average, although there's a lot of overlap, and this is not real data, I just sort of trumped up, but it's kind of like this. On the average, if you look at the overall population of whites, the measured IQ is higher than the overall population of blacks. If you look at boys versus girls, and look at quantitative SAC scores, boys on the average do better than girls. Now the question naturally arises, and you're all aware of this, to what extent those differences are for genetic reasons and to what extent they are for environmental reasons. Now there are 2 points, very important points, to be made about this. The first point is that whenever you have 2 groups, such as blacks and whites or girls and boys, where any damn fool can look at them and tell which group they're in, then immediately there is a possibility and the likelihood of differential treatment. So they immediately have different environments because of their color or their sex. And therefore, it is exceedingly difficult to figure out how, since people aren't treating them the same way, it's almost impossible to evaluate what the impact of environment is. And therefore, it's impossible to figure out the relative impact of environment and genes. So, whereas there are these differences, and whereas it seems like a reasonable question, or it seems like a possible question, to ask to what extent these differences between these groups is because there's differences in the genes between them or differences in the way that they're reared and so on and treated, it's almost impossible to figure it out. There might be ways of subtle sufficient. There probably are ways to do it, but they're probably complicated and they would be subject to disagreement among scientists. But it could be done, and is done to some extent. But that raises a second question, which is in some ways a very interesting one, which I don't know. I mean, we will all have different opinions about it. Okay, suppose one could find out or can find out. Should one? Okay, what's the information? What's going to be done with the information if we get it? Is it possible that the information will be so misused, if we get it, that we shouldn't even try to find out? Well, that's one point of view. On the other hand, if you knew what was causing these differences, that might put you in a better position to get rid of them, ameliorate them. We'll talk more about this in a few minutes, but that might put you, if you knew what their cause was, then you would be in a better position for getting rid of them. And as I say, I'll talk about more of that in a minute. So that's a reason, even if you think that they might be put to misuse, that's a reason for finding out. Actually, I'm sort of curious. So 2 choices. We should try to find out, we should not try to find out. How many think we should try to find out? How many think we should not try to find out? Okay, yeah. And that's, I'm surprised there's not more on the other side. So the majority of you, more of you think that we should try to find out. I think that's probably my own personal judgment, although I don't have a very firm judgment on the matter. Possibly. But it's a very interesting question and worth thinking about. But and now this is really going to make this question more pregnant. Suppose you have a trait that you absolutely know that all the variation in the trait is for genetic reasons. What does that mean from a practical point of view? Does that mean tough, you're stuck with it, whatever it is, whatever the trait is, you're stuck with it? And the answer is basically not necessarily, though it's a very complicated matter. Here, I'm going to tremendously simplify the thing, but the essence will be correct. And I'm not going to use data with IQ and humans because, first of all, because there isn't the data, and secondly, because somebody would probably get angry at me for something I would say. So I'm going to talk about milk yield in cows. Now, this data I'm going to show you is, again, I sort of kind of trumped it up, but I've trumped it up based on real live data. In fact, on a very famous science article from about a couple of decades ago now, basically said all this, but not in quite the schematic way that I'm going to present it. So if you look, different breeds of cows have different milk yield. Typically, some have higher, some have lower. And if you typically they graze on just, mixed grass pastures. And if you look, it turns out that some breeds, which I'll read A here, which are really great milk producers, and there's B and C are in between, and breed D here is a really lousy milk producer. And you can ask, well, is that because of some, the way the cows are treated and reared and upbringing and fed and so on and so forth, or is it for genetic reasons? Is it because of the breed? And it turns out it is because of the breed. And the way they find that out, believe it or not, is with there are identical cows have identical twins too, and you can raise the identical twins on different pastures, and same experiments. And you come to the conclusion that the lion's share of it, virtually all of it, is genetic. Okay, so here we have a nice genetic trait. Now let's follow. This is very interesting. What these agricultural geneticists that did the study did. They said, okay. First of all, this on the left is just what I just showed you, just repeated. But let's look on the right. What they did is they took, and whereas normally pastures are mixed grass, they sowed and scrupulously weeded experimental pastures where one was grass type 1, one was grass type 2, one was grass type 3, and one was grass type 4, which in normal wild pastures, the pastures had all those kinds of grass in them. So they had these pure pastures of each kind. And then they tried raising each breed of cow, or allowing them to live, each breed of cow in each type of pasture. Not the same individuals, but individuals of the same breed. And what they discovered was that everybody that was reared on grass type 1 had a high milk yield, no matter which breed they were. And everybody that was fed on grass type 4 had a low milk yield, no matter which breed they were. But it was all genetic. So what is this telling us? What the hell is going on? It's not very hard to figure out. The genes are obviously important. What are the genes doing? Yeah.
Knowing the cows which kind of grass they like to eat?
Yeah. The genes are influencing grass preferences. Exactly. So what's going on, apparently, here is that the gene differences are causing a grass preference difference, which are causing a milk yield difference. So it's absolutely genetic, but the genes are working via something that you can manipulate perfectly well in the environment. Okay, that's good, but of course it's not always going to be so for all kinds of traits, but there's some further complexities. Let's look at the following imaginary situation. First of all, I'm going to look at two things here. I'm going to look at the situation for milk yield in cows and the situation for intelligence. We'll talk about that one in a minute. First of all, milk yield in cows. We've been looking at yield. But there's, the traits of a cow go beyond its yield. It's how it looks, how happy it is. We all know that the milk of the contented cows is better, so on and so forth. So let's have another dimension here. Contentment of the cow. Contentedness of the cow. Okay, so let's look at this. Let's just look at the two extreme versions, at genotype A, the good one, the good genotype, and genotype B, the in quotes, bad genotype. bad for milk yield. So the direct effect of the genes is that these guys, the A's, like, in quotes, good grass that's good for milk yield, and these guys like junk food grass, it's bad for milk yield. Now, we can rear these animals, we can get around this by rearing the animals on the kinds of pastures that will give us the result we want. We want milk yield. So, but we can rear each of these guys on normal mixed pastures, which is what normally happens, of course. Or we can say, okay, I want my milk yield to be high, so we're going to make only good grass available, only the type 1 grass available. So everybody's going to have high milk yield. So what's going to happen then? So if we take breed A and rear it in mixed pastures, it will have good yield. If we take type A and rear it, because it'll choose type 1 grass, if we rear it on only the good grass, it'll have good yield. With type D guys, if we rear them on the normal mixed pastures, they'll have bad yield because they'll choose the junk food grass. But if we force them to eat the good stuff, they'll have good milk yield. So that's great. We'll get exactly the result we want. But let's look at the second line, their degree of contentedness. Well, these guys are kind of normal. They like good grass, but they're getting a mixed pasture which has a reasonable amount of good grass in it, and so they're contented enough. These guys prefer good grass, and only good grass is available. They're not only contented, they're probably ecstatic, but it's contented here. I actually almost changed it this morning to ecstatic, but too long a word, so I didn't. These guys are the ones that have bad yield because on a mixed pasture, but they can find the stuff they like, so they're contented enough. But the interesting case is this one. We have these guys, we make only good grass available, so we get the yield we want out of them, but they're miserable because they're having to eat this crud they hate. Okay. Okay. Well, that's kind of that's not 100% implausible. Now let's look at a totally hypothetical version of the same thing for IQ. And let us suppose, this is not the case, this is just to think about the problem. Let us suppose that comparable to the grass preferences in the case of milk yield, that what the genes for good and bad intelligence here in our imaginary example do is these guys are normal learners. They learn under normal circumstances. These guys learn only when they're excited. So, you imagine this little kid, and you have to, in order to want to teach them anything, you've got to chase them around, get them all excited, or you've got to make loud noises. You've got to do things to keep them jazzed, really wild, in order for them to learn anything. Okay? There could be kids like that. Indeed, maybe that's, maybe hyperactivity or something like that. I don't know. In any case, you can imagine there could be a gene like that. Okay. So, given that, we can, of course, just rear the kids normally. If we rear the kids normally, this kid will learn normally and get smart and be psychologically normal, I guess. This kid will, who learns only when he's excited, and who we're rearing in the normal way, doesn't learn much at all and gets kind of stupid. Whether he's neurotic or not, or normal, I don't know. I mean, this is a funny situation, so I just put a question mark there. But suppose now we say, okay, we know what's wrong, the problem with these kids is. Let's fix it. Let's treat all kids in a way that, that will help these guys. We'll make everybody excited. Let's think about that, just like we did with the cows over here. Forcing them on good grass. Here we're going to keep everybody excited. Same treatment for everybody. Okay, well, first let's go over here. What's going to happen over here with these guys that didn't learn normally is now it turns out they do learn. And in fact, they get smart, maybe. Imagine this is a possibility. But this kid's been kept excited all the time. Every time you wanted to learn anything or doing things to jazz it up, it's going to be a nutcase. It's going to be neurotic, almost for sure. Okay? So you have a good effect and a bad effect. And now we also have this normal kid who you figure, well, if it's good for one, it's good for all. Let's keep everybody excited. This kid doesn't learn well at all when he's excited, probably. And he's also going to be made neurotic. So this kid really loses out. He becomes both stupid and neurotic. All right. All right. There is a moral to this story. And whereas the example is kind of artificial, a little silly, though not so silly, like something like this, almost exactly like this, could be true. It's not, and there's no reason to think it is, but one could imagine the possibility of it. In any case, there are some very important morals from this. Each one of them is equally important. First is, genes don't tell the whole story. And in fact, it may be possible to compensate for genes with unwanted effects or undesirable effects by environmental and rearing manipulations. An example of that over here, an example of that over here. That isn't always going to be the case, but it may often be the case. We know enough now about the way things develop to realize that might well be very often true. And so for any given trait that you want to promote, you might be able to find ways of getting kids with almost any genotype to do better, or have that trait in a form that you like, the society or you or your parents or whatever, or the kid, would be better. So that's point one. So you might, and it's going to take research to find out, but there could often be that. And that's in some ways the most important. I don't know, they're all important. That's probably the most important conclusion of this, is that you might be able to compensate. But in order to do so, you have to do a lot of research to find out if there really are ways to do it. You don't know in advance. There may not be practical ways to do it, but there might be. I mean, a good example here is hyperactive kids giving Ritalin and things like that seems to work pretty well. And, you wouldn't have known that without a huge amount of research. I mean, there are issues about the use of that drug, but it's probably a good thing overall, at least for some kids. Second moral is that whereas you might be able to do things to compensate, there may be costs. So over here, we made the kid smart, but we made the kid neurotic. Okay, so development is very complicated, and if you try do things to manipulate, and everything's all these pleiotropic issues. So if you do something to increase one trait, you might do other things to do something bad to other traits that you also care about. So there may be costs. For example, in this case, smart but neurotic, or good yield or discontented, and so on and so forth. Third, and also very important, is that if this is the kind of game you want to play, of trying to make rearing conditions and educational conditions that take account, that compensate for variations in genes, and there certainly are variations in traits driven genes, you have to keep in mind that what works for D may hurt A. So you may do something that would be good for the kids, for the D, the guys where you don't like the way things turn out, but you can't necessarily use those same treatments with a normal kid. Because as here, we made the kid both stupid and neurotic by treating him the way that at least made this guy smart, though also neurotic. So what works for D may hurt A. Therefore, if you're going to play this kind of game, you may have to tailor nature to nurture. That is to say, you may have to find out what the genotypes are in order to create a rearing and educational regimen that is suitable for that particular genotype. But if that's what you're going to do, you've got to know what the genotype is. And this goes back to the question of, should we try to find out or shouldn't we try to find out? Life is complicated. But those are some of the issues. Okay, I'll probably I actually have a little bit more time, but I think it's enough for today. I'll review this a little bit, sort of where we've been overall at the beginning of next time, and then we'll go on to our next topic. I'll get slides to you for the next topic over the weekend or later today or something.
I just enrolled in the class yesterday.
Uh-oh.
But, I listened